Hey everyone, welcome back to the Foundations in Pre-Calculus 10 videos. In this video, we're going to look at Lesson 5 from Chapter 7, which is looking at using an elimination strategy to solve a system of equations. So the last strategy that we're going to learn about is how to solve a linear system by elimination. And so when we solve by elimination, we are literally trying to eliminate one of the variables by adding or subtracting the two equations. So the name really speaks for itself. You're trying to eliminate one of the variables, and it doesn't matter which variable you're going to eliminate. I would just suggest trying to eliminate the one that looks easiest to eliminate. And we're going to go through how to eliminate variables by looking at our first example from our notes. So here we're going to solve this linear system by elimination, and then we're going to verify our solution. And so remember, to verify our solution, it is exactly the same that we did in our last lesson, where we just plug in our solution to each of those equations, and we show that it holds true for both equations. Okay, so in order to solve this system, your first step here is you want one variable to be exactly the same in each equation, except where one's a positive value and one's a negative value. So I'll write this down. So step number 1 here is, so you want one variable in each equation to look the same except one is positive and one is negative. So here we're going to look at our two equations. Here we have 2x plus 7y is equal to 24, and we have 3x minus 2y is equal to negative 4. So typically what we'd always try and look for is if we can make one equation look like the other. But in this case here, these are all prime numbers that are attached to our x and y variables, which means that we're going to have to manipulate both equations. So typically you want to try and go for the easy route, where if you can make, where you only have to change one. Like say if this were an 8y, then you'd only have to times this equation here by 4 to make them the same. But in this case here, it's a little bit more complicated. Just because we don't, all of those numbers are prime, so we can't just change one equation. So here what I might do is I might work with the easiest numbers, and so here I might work with 2 and 3. So a number that both of those can divide into is 6. So what I'm going to do is I'm going to multiply the entire equation by a number to make this 6. So 6 divided by 2 is 3, which means I'm going to multiply everything here by 3 to make this first number positive 6. So then in my second equation, what I want is, now I want negative 6. So if you multiply by negative 2, that would make this first value negative 6. Because remember, you want one positive, one negative. So from here, what I'm going to do is I'm going to go ahead and distribute this 3 into each part of my equation. So I have 3 times 2 is 6x. 3 times 7y is positive 21y. And then 3 times 24 is 72. Now I'm going to go ahead and do the exact same thing for my second equation. So I'm going to go ahead and shoot my arrows. So here we have negative 2 times 3x is negative 6x, which is exactly what we want. Remember, one positive, one negative. Then we have negative 2 times negative 2y is positive 4y. And then negative 2 times negative 4 is positive 8. So then what we want to do here is, step number 2 is that we're going to add the equations together. So what I'm going to do is I'm going to draw a bar over this, or I guess underneath our system, and I'm going to just add the equations, and I'm going to add those like terms. So I'm going to go work in those vertical columns. So one thing that is really important is that if this were not in the same order, like say you had X, Y, and then a number, then you need to make sure it looks exactly the same. So if the number's on the right-hand side, you need to make sure your number's on the right-hand side for your second equation. So you need to line everything up exactly as you see it in each equation, okay? Really important step. So this one here is already in our perfect order, so we can just go ahead and add those two together. So 6x plus negative 6x is 0, so I don't have to write anything there. Then we have 21y plus 4y is 25y. And then 72 plus 8 is 80. So now here I'm left with just one single linear equation, so I can go ahead and solve for y. So look at how nice and simple that elimination breaks down that process. So here what I'm going to do is I'm going to get y by itself, so I'm going to divide by 25. Make sure you do it to each side. So what we're left with here is y is equal to 80 divided by 25, which if this one here reduces to a nice easy decimal where we're not having any repeating numbers or it's not a terminating decimal, then we want to make sure we would leave that in simplest fraction form. But in this case, 80 divided by 25 works out to a really nice, I guess, easy decimal, which is just 3.2. So here we don't have to round, so leaving it as a decimal here is fine in this case. Otherwise, though, I would recommend leaving it in fraction form. Just make sure it's a reduced fraction. So now that we have y, now this is essentially the exact same process from here that we did for substitution. Now we found one of our variables. Now we can go ahead and solve for the other one by using substitution. So here we're going to solve for our other variable, which is, in this case, we're going to solve for x. So we're going to choose one of our equations. Doesn't matter which one. If you want to choose the one that has the smaller numbers, it might be easier to work with. So in that case, I might choose the second equation. So I have 3x minus 2y is equal to negative 4. And I'm going to substitute in 3.2 in for y. So we have 3x minus 2 times 3.2 is equal to negative 4. So then simplifying this multiplication here, we have 3x. And negative 2 times 3.2 is negative 6.4. That's equal to negative 4. Then we're going to try and get x by itself. So our first step there is we're going to get rid of this negative 6.4. So we're going to add 6.4 to each side. So then here we have 3x is equal to 2.4. And then our last step there is here we're going to get rid of that 3, so we're going to divide by 3 on each side. And this one here works out once again to a nice decimal, which we get 0.8. Alright, so therefore, now that we have our x and y variable or values, so therefore our solution is x is 0.8 and y is 3.2. So now our last step is, yes, we do have an answer, but we need to make sure that answer is in fact correct. So now we need to do our verification step. So we're going to verify that this answer here works in both equations. So we need to do our first equation first, which is 2x plus 7y is equal to 24. We're going to plug in our x and y variables. So we have 2 times 0.8 plus 7 times 3.2 is equal to 24. So 2 times 0.8 is 1.6, and 7 times 3.2 is 22.4, and that's equal to 24. Adding the two together, we find that 1.6 plus 22.4 is 24. So 24 equals 24, so we know that that solution works out for our first equation. That's awesome, that's great news. Now we're going to copy, paste, repeat into our second equation, which is 3x minus 2y is equal to negative 4. So you have 3 times 0.8 minus 2 times 3.2 is equal to negative 4. So 3 times 0.8 is 2.4, and negative 2 times 3.2 is negative 6.4. That's equal to negative 4. Subtracting those two numbers, 2.4 minus 6.4, you find that you get negative 4. And so once again, we show that our solution checks out in both equations. So that is everything here for this video. So if you guys have any questions, make sure to come see me in class, or you can text me on Remind 101. Thank you guys so much for watching.